Hi and welcome. We've got a series of videos on differentiation, 3 videos coming your way, all linked with gradients of curves, and we're going to bring that work and connect it to all the work you're doing on coordinate geometry earlier on. So we're going to be looking at tangents and normals to curves and a whole bunch of stuff related to that. So here we go. So initially we're going to be looking at gradients, finding the coordinates for a point given the gradient, tangents and normals, and then increasing and decreasing functions. So the first video, we're just going to be looking at it doing 2 ways around. First of all, can you find the gradient of a curve at a given point? And the flip side of that, which is, if you know the gradient, can you work out what point it's occurring at? So here we go. It's a nice short video, this one. So first question, we've got to find the gradient of the curve, y equals x cubed minus 4x squared minus 5x plus 3 when x equals 3. And you did see an example of this briefly in the previous video. So here we go. There's our curve. So if we want the gradient, we need the gradient function, so we're going to have to differentiate. There it is. Again, I'm going to very quickly put that up on the screen because hopefully you should now be familiar with the old idea of bring the power to the front, take one off the power. So there's our gradient function. And very straightforward when you say, well, when x is 3, what is the gradient? Well, you'll notice our gradient function is in terms of x. It basically tells us what is the gradient at any point on the curve. So all we're going to do is plug x equals 3 into there. And so when you chuck x equals 3 in, we've got 3 times 3 squared minus 8 times 3 minus 5. And so that tells us that the gradient of the curve at that point is minus 2. Okay, job done. The second one is the other way around. We're saying, like, this time we're being told the gradient, and we've got to go and work out what is at what point on the curve is that gradient occurring. Where is the gradient? Minus 3. And we've got a slightly more complex curve in this case. So we've got x squared plus 3x plus 1 all divided by x. So here we go. Hopefully, first thing we know we've got to do is tidy up this. So we've got to do the dividing to make sure we've got all these 3 terms written as individual powers. So I've got x squared divided by x, 3x divided by x, 1 divided by x. So let's do that bit first. So that becomes that. And then the next step before we can actually get busy with the differentiating is to take this term on the end. And it's currently a fraction. We need to write that as a power. So let's write that. There it is, x to the power minus 1. Now we're all set up to do the differentiating. So here we go. So x to the power 1 is going to become 1. Think about what's going to happen there. And again, minus the power to the front. And off we go. So do the differentiating and we end up with 1. That's that term there. The 3's disappeared. X to the minus 1 has become minus x to the minus 2. And I've written that as 1 over x squared. Because again, it's just it's a little bit easier to deal with it if we write it now back as a fraction, because we're going to have to do some work on it when we set this equal to minus 3. So we're told in the question that the gradient is minus 3. So we're saying the gradient, this thing here, has got a value of minus 3. So let's put the minus 3 into there, which gives us now an equation we've got to solve. So what we're going to do is just tidy that up a little bit. I think what I'm going to do is just kind of take that over to the side so we get rid of the minuses, bring the minus 3 back this way. It's up to you how you choose to rearrange it, but that's where I've ended up. So now move the x squared over. We get x squared equals a quarter. Because I've taken the x squared across there and taken the 4 back that way, and then we've got to do the square rooting. So we get x is plus or minus a half. So we've actually got 2 points on the curve where the gradient is minus 3 when x is, there's my cursor, when x is positive a half, and also when x is minus a half. The question specifically asks for coordinates, so I've now got to find the y coordinates, and to do that I've got to put my x is half back into here, and then do the same with x equals a minus half. That's what I'm saying. So we've got 2 points we've got to deal with. Here we go. So plug back in. So when x equals a half, we get that, which ties up all becomes 11 over 2. And again, you've got to calculate. So if you're not particularly happy doing that all in your head, you can just whack it into a calculator. And when x equals minus a half, we end up with y equals a half. So what we've got there is our 2 coordinates.